Well, we're down to the last little nitty-gritty stuff here in chapter 7 before we go on to something called logarithms, which is extremely cool, by the way. I want to show you how to solve exponential equations. It's actually very, very easy. How to solve an exponential equation? Simple. Write each side of the equation, if you can, in the same base. Oh, interesting. If necessary, you might use the exponent laws. Drop the bases, do a little bit of algebra. There you go. Now you're probably saying, what are you talking about? Take a look at this guy right here. One of the coolest things in the world is look at the bases. One of the coolest things ever that you'll notice is that 81 is actually 3 to the power of 4. Don't believe me? Simple. Go to your calculator. 3 to the power of 4 is in fact 81. Now, how did I know that? Well, a lot of it is practice, a lot of it is experience, but a lot of it is guess and check. But the cool thing is always try to make it the same as this base. I mean, look at this one. This is 3, that's 27. So the bases are going to be 3 again. Really nice. So watch this. This now becomes 3 to the power of 5x minus 1 equals to, watch this. This is now 3 to the power of 4. That's what 81 was, to the power of 3x. Now, you know and I know you can do a little bit of fancy stuff here. The fancy stuff here is simple. Watch. Cross the bracket according to exponents laws. So this is 3 to the power of 5x minus 1 equals 3 to the power of 4 times 3x. That's it. Now look. Do you see that these guys are the same bases on both sides? You can cancel them now. Yeah, that's the cool part. So this becomes 5x minus 1 equals to 4 times 3 is 12x. Bring the 5x over, you get minus 1 equals 2. Combine like terms. Minus 5x from both sides, right? Minus 5x from both sides. That's going to give you 7x. Divide by 7, and look at that. X equals to be 2, negative 1/7. There you go. That's how you solve these kind of questions. It's really straightforward. Watch again. Look at this one over here. I told you already. Try to get it in terms of 3. So if you look at this, this is 3 to the power of 4x times 3 to the power of 1. Like bases, what do we know about exponent laws? Like bases means we add the exponents. So this is 3 to the 4x plus 1. Look at that. 27, you should know, is 3 cubed by now. So 3 cubed times 2x, right? Over the bracket, you multiply. So this is the same as saying 3 to the 6x. Look at that again. 3's cancel, leaving you with 4x plus 1 equals to 6x. Combine like terms, subtract the 4x from both sides. Check this out. Boom, that's gone. 1 equals to 2x, divide by 2, x equals to a half. Ha! Well, that's so simple and so much fun, isn't it? Well, let's keep on going. Let's go to this guy right over here. Okay, what happens if this is a fraction? So what? You know that when it's a fraction like this, you can flip it and bring in a negative. So this is actually 9 to the negative x. Oh, you're kidding me. No, I'm not. Right? Look at this guy here. If you want, you can even take this guy one step further. And you can make this as a 3. So isn't this 3 squared to the negative x? So wouldn't this be 3 to the negative 2x? Yep, that's about as simple as you can go. Now, why did I take it down to 3? Because I looked over on this side here and I remember you can't make 27 into a power of 9. Just doesn't work very well. But I can make it into a 3, and I can make this 9 into a 3 and check out what I'm going to do. This is going to freak you out. Watch this. I'm going to just, let me clean this up just a little bit, and you'll see what I mean. 27 to the power of, with a base of 3 is 3 to the power of 3, right? On the outside, there's my x. On the bottom here, isn't this 3 squared to the power of 2x minus 1? You betcha. Now, check this out. When we go across the bracket, we multiply. So that's easy enough to tell me that that's going to be 3 to the power of 3x. But how about this mess? How about this mess? Well, yeah, I'm still going to go across a bracket, which means I'm going to multiply. Which means if you think about that then, this is 2 times 2x minus 1. Okay, so this is 3, 2 times 2x minus 1. Do a little distribution here. I get again, oh, I need some more room because I'm running out of room here, equals to 3 to the power of 3x over 3 to the power of 4x minus 2. Now, bases are the same. According to Math 10C, what do you do to those exponents? You know and I know you have to subtract them. So isn't this 3x minus 4x minus 2? Distribute, distribute. This will be 3x minus 4x plus 2, which gives you minus x plus 2. That's your new exponent. So this hasn't changed for a while, so I'm just going to write it down here as 3 to the power of minus 2x. Okay, let's extend my page a little bit here. This is now going to be equal to what we figured this guy out to be, 3 to the power of minus x plus 2. Look at that. My bases are the same. Goodbye, bases. Minus 2x equals minus x plus 2. Bring the x over by adding x to both sides. I got a minus x equals to 2, so x equals to minus 2. Oh my goodness, that was just an incredible question. Okay, last one. Ready? Let's go back all the way up to this one. There's D. Now notice this says 4/7. Okay, so maybe I can get something in terms of 4 and 7. I don't know. Let's look at 64 here. Think about it. Well, 4 squared is 16, but 4 cubed is 64. Oh my goodness. So I can rewrite this right now as 4 cubed. I wonder if 343 is going to have to do something with 7. Let's go to our calculator and let's see. I wonder if that's 7 cubed. Oh my, it is. It's 343. How do you like that? So this is 7 cubed all over minus 2x plus 1. Now check this out. This is really cool because you know upstairs, downstairs mailman. Do you remember upstairs, downstairs mailman? Yeah, go back to that first podcast in this section and you'll see what I mean. Okay, so this is the same as saying 7 over 4 to the power of 3. But I have this power already on the outside, minus 2x plus 1. So what? Hold on, we ain't finished yet, baby, because look at this. This says 4/7 to the power of 5x. You know what? Let's make these bases the same. The only way you can make the bases the same is if you reciprocate it. Right? You gotta flip it. You gotta flip it, flip it, flip it. Here we go. Let's flip it then. So if we flip this, this becomes 7 over 4. This becomes minus 5x. This guy is still, oh, let's go across the bracket. This is going to be 7 over 4 times 3 minus 2x plus 1. Ah, ha, 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 ah, look at this. 7 over 4 and 7 over 4 cancel. Look what I'm left with. Look what I'm left with. This is just absolutely gorgeous. I'm left with minus 5x equals to, distribute, distribute, equals to minus 6x plus 12. Is it 2x minus 1? 2x plus 1? Yeah, oh, sorry. 2x plus 1. So that would be plus 3. My apologies. Now, look how simple this is. Add 6x to both sides. Check this out. That's gone, leaving you x equals to a nice, beautiful, positive 3. Oh, these exponential things are so much fun.